Now let me give you another example. Same thing, we're going to write in slope-intercept forming graph. But we have a little bit of a mess here. Remember, we want to make it look into y is equal to mx plus b. So the y has to be by itself, and all the other terms must go to the right side of the equation. So we could move the 5x to both sides of the equation. So 5x, negative 5x cancels out. And 10x minus 5x is, of course, 5x. Now we move the 15 by doing the opposite, additive inverse. So 15 and 15 cancels out. 5y is equal to, the x term comes first, minus the 15. Now we solve for y by moving the coefficient 5 by dividing to all the terms by that 5. And 5 and 5 reduces to become 1y, or simply y. Here, nice. 5 and 5 reduces to become 1x, or simply x. And minus 15 over 5 is simply 3. Wow, that's clean, huh? Nice and neat. So we could graph that. Here we go. So the question is now, what is the starting point? The y-intercept, that is. What is the starting point? Well, it is minus 3. Minus 3. You have to include that sign next to it. So from the origin, on the y you go 1, 2, 3. Minus 3. Bam! From there, what's the rise over run? Well, the slope here is 1. And how do you write that in a rise over run format? It is 1 over 1. So it's up 1 and then over 1. And you could keep on doing that like a step. Up 1, over 1. Up 1, over 1. And you can even go down. Down 1, left 1. As long as it's negative and negative, because they're also 1. So now, I could draw the line through those 2 points, and you got yourself a graph. Okay? And this line now represents the equation y is equal to x minus 3. It is a common courtesy in algebra to label all your lines the function. You try that one. Good. You said now, all right, it's kind of like what we had here in example 3. Let's go ahead and move the x term. So you said minus 2x to both sides of the equation. So 2x minus 2x cancels out from the left. You are left with 2y minus 4. Combine the x's first. It's like saying 1x, take away 2x, you owe somebody 1x, negative 1x. Plus the 5 we haven't done anything with. And now 2y tells a negative 4. You, go on that side. So you do the additive inverse and line them up with a like term. So you got 2y is equal to negative x. 5 plus 4, of course, is 9. And y, finally, to solve it, divide to all the terms by the coefficient 2. So y is equal to negative 1/2 x. And I leave it as a quotient so that I could see the rise over run. Plus, 9 over 2, just like the last example number 2. We have a y-intercept that's a quotient. So you better be careful here. So we're ready to graph. Okay, so what is the starting point? What is the y-intercept? It is 9 over 2. And mixed numbers, like back in 4th grade, 2 goes into 9 4 times and a half. So on the y-axis, the starting point is 1, 2, 3, 4, 5 and a half. 4 and a half. So it's just before the 5. Bam! And that is my y-intercept, 9 over 2. From there, what's my rise over run? It is down 1 over 2. Or up 1 over negative 2. Either way. Okay? So now be careful. We talked about it on example number 2. We're going down 1 whole, not half. So it's from here, down 1. You see that? And then Hey, I am so sorry about that. It seems like the memory got full on the camera. So here's the rest of it. Remember to go down one whole, okay, from 4.5. Don't forget to go down not just a half space, but one whole space. And then from there, over 2. 1, 2. So that's the second point, okay? So when you draw the line, you have a slope that's negative going down from left to right, which represents the negative slope over here. Okay? And then this equation, y is equal to 1/2 x negative plus 9/2 represents this negative slope line going through the point 4.5 or 9/2 right over here. Okay? All right.